Anthony Raj. He has pursued his bachelor's, master's, and MPhil in physics. He then went on to pursue his PhD in physics at the University of Madras as well. He then went on to work as a lecturer at Tiruvalluvar Arts and Science College and Idya Engineering College for Women. Since the year 2006, he works as the lecturer and assistant professor at Loyola College, Chennai. With regard to research, he has published several papers in international journals, namely Radio Wave Propagation over Salem, Linear and Non-Linear Optical Properties of Pure and Doped Selenium Malate Single Crystals, and many more. He has also attended several conferences and seminars, namely International Conference on Materials Science and Technology, National Conference on Higher Education at Crossroads held at Loyola College, National Seminar on Crystal Growth 12 held at VIT University, and many more.
Welcome to UGC lecture series BArch Semester 1 Mathematics Lecture 1. In this lecture, we are going to discuss trigonometric functions. We know trigonometric functions is obtained from a triangle. In that trigonometric functions, in this lecture, we are going to discuss elaborately about sine function, cos function, tan function, then finally summary. These are all the concepts we are going to discuss in this lecture. Sine function. You know, sine function is a trigonometric function which can be obtained from a right angle triangle. Consider a right angle triangle. In that right angle triangle, one angle will be 90 degree. Sum of other two angles are equal to 90 degree. Out of that two angle, consider one angle. Then side opposite to that angle is assumed as opposite side. Then side opposite to right angle is assumed as hypotenuse. Then side adjacent to the considered angle is the adjacent angle. Like this, we can get the three different sides in a right angle triangle. Considering the three different sides, we can obtain the trigonometric ratio sine of an angle by this formula. Sine of an angle theta is equal to opposite side by hypotenuse. So here sine of an angle is obtained as a ratio of two sides of the right angle triangle. Apart from this definition, this sine function can also be explained or defined as a function like this. So here a unit circle is assumed. Center of that unit circle is fixed at the origin of the coordinate system. You know, unit circle means a circle which has a radius 1. It can be 1 centimeter, 1 meter, 1 millimeter. Like that, it can be any unit, but the magnitude of that measured unit should be 1. So here a unit circle is assumed. Center of that unit circle is fixed at the origin of the coordinate system. Then a line is dropped, a line is drawn from the center of the coordinate system to any point on the circumference of the circle. Now the value of this point will be x comma y. Since it is a unit circle, the value of y function is equal to 1. So the value of that y is taken as sin x. This is how sine function can be defined by assuming a unit circle. Here right angle triangle is obtained. In the earlier side, we have seen that sin theta is equal to opposite side by hypotenuse. Here sine is defined as a function. Here there is x is the angle, then opposite side to this axis, this line which is dropped to the x axis, which is a line dropped from any point on the circumference of the circle to the x axis. So this side is the opposite side to the angle x. Then hypotenuse is a side opposite to the right angle. Here this is that right angle, that is 90 degree. So this is hypotenuse. So sine function sin theta is defined as opposite side by hypotenuse. This is how sine function can be defined and understood. Now, the sine function is a periodic function. You know, periodic function means a function which repeat itself after certain interval. This is how periodic function is defined. That means sin x. So, if you put x is equal to 0, then sin 0 is equal to 0. If you put x is equal to 90 degree, sin 90 is equal to 1. So, this is given in this tabular column. So, when you substitute x is equal to 0, sin x becomes 0. When you substitute x is equal to 45 degree, then sin x value is obtained as 0.71. Then when you substitute x is equal to 90 degree, sin x value has become 1. So, here a linear increase has taken place, 0, 0.71, 1. So, this is that linear increase part, and it has reached the maximum value. Then when you substitute x is equal to 135, now the values start decreasing. So, it become 0.71. So, 0.71 will be somewhere here. When you substitute x is equal to 180 degree, then the value of sin x becomes 0. So, here is that 0 value. Again, when you increase the x value to 225, then the value of sin x becomes minus 0.71. That means it has gone to the fourth quadrant. You know, this is the first quadrant, second one, third one, fourth one. So, has gone to minus 0.71. Here x value is positive, y value is negative. So, minus 0.71 will be somewhere here. Then increase it to 270, then sin x value become minus 1. It has reached the negative maximum. So, the function has reached the positive maximum at 90 degree and negative maximum at 270 degree. When you increase the x value further, like 315 degree, then the value of sin x becomes again minus 0.71. Then when you increase that to 360 degree, sin x value becomes 0. So, here we got the complete wave. This is in the form of wave. When you increase the x value further, the pattern repeats. So, this is the initial pattern, that is from 0 to 360 degree. If you increase the value of x further, the pattern repeats again, so that we can say sine function is a periodic function. Here we substituted the value of x in degrees. Instead of degree, if you use radian, you will get the same pattern. You know, pi radians is equal to 180 degree, then 1 radian is equal to 180 degree by pi. So, this is how radian and degree can be related, you know that. So, from this explanation we learned that sine function is a periodic function. It reaches both the positive maximum and negative maximum. So, the domain of the sine function will be plus 1 to minus 1 or minus 1 to plus 1. So, here we saw the repeated pattern in the positive side of the x axis. If you decrease the x value from 0, it is not shown in the tabular column. If you do that, you will get the same pattern here. First it reaches the negative maximum, again comes back to the 0, then reaches the positive maximum, then comes back to 0. In negative side of the x axis also the pattern is repeated. So, sine function is a periodic function with period 2 pi radians or 360 degree. This is how sine function can be learnt elaborately. Now, periodicity of sine function. I told you earlier that sine function is a periodic function, or it repeats itself every 360 degree or 2 pi radians. So that in equation the sine function can be written like this: sine of x is equal to sine of x plus 2 pi. So, if the periodicity is 2 pi, you will get the same function. This is how equationally the periodic function can be represented. Next, we will move to the cos function. To define the cos function, again same right angle triangle is taken. Here this right angle triangle is drawn here. This right angle triangle is given here. Here this is the angle assumed. This side is the opposite side, and this side is the hypotenuse, and this side is the adjacent side. Definition of cos function is cos theta is equal to adjacent over hypotenuse, or cos of the angle is defined as cos theta is equal to adjacent by hypotenuse. Again, you imagine a unit circle. To understand the cos function, center of that unit circle is fixed at the origin of the coordinate system. Then connect any point on the circumference of the circle in the positive quadrant with the origin of the coordinate system. So, this is the line drawn. Then angle subtended by this line with the horizontal axis is considered as x. Then the trigonometric cos function is defined by the value of x axis. So, this is that value of x axis cos x. So, definition of cos x is the ratio between the adjacent side and hypotenuse. This cos function is also a periodic function. To understand that periodic function, again substitute values of x in the cos function, you will get some value, then plot that cos value as a function of x, you will get a graph like this. So, here when you substitute cos x value as 0, cos 0 becomes 1. So, x value is 0 here, cos 0 is 1 here. Then when you substitute x is equal to 90 degree, then cos 90 is equal to 0. So, this is that 90 degree, the value of that cos 90 is 0. 45 cos 45 will be somewhere here 0.71. Then substitute 135 degree for x in cos x, you will get minus 0.71 somewhere here. Then substitute 180 in cos x for x, you will get minus 1. Then 225 again minus 0.71, which will be somewhere here. Then 270 degree as x value in cos x, you get 0. So, 315. So, substitute 315 in the place of cos x, you get 0.71, which will be somewhere here. Then substitute 360, again cos value becomes 1. So, for cos 0 the value is 1, then for cos 360 again the value is 1. So, this is how we can understand that cos function is a periodic function with period 2 pi. Then the domain of that cos function will be again minus 1 to plus 1. So, this is how the domain of a cos function can be learnt. Now, we can compare this cos function and sine function. For cos 0, the value of cos x is equal to 1. When x is equal to 0, cos x is equal to 1. When x is equal to 0, sin x is equal to 0. So, there is a phase difference between the sine function and cos function. That phase is here 0 degree 0. When sine reaches 0, sine reaches 0 at 90. So, the phase difference between the cos function and sine function is pi by 2 is the phase difference between the cos function and sine function. Then this cos function repeat its pattern after every 360 degree. So, that cos function is also a periodic function with periodicity 2 pi. Then we can see the same pattern in the negative part of the x axis also. So, whether the x value is positive or negative, cos function repeats its style. So, cos function is periodic both in negative domain and positive domain. Then the periodicity of this cos function is 2 pi. So, periodicity of cos function says that 360 degree or 2 pi radians. How equationally we can represent this cos periodicity of cos function? If f of x is the cos x, then we learned that periodicity of this cos function is 2 pi. So, which is equal to cos x plus 2 pi or any n number of 2 pi. In general, we can write this as cos x is equal to cos x plus 2n pi, whether this is 2 pi, 4 pi, like that. For every period, every 2 pi, this cos function repeat itself. This is how periodicity of cos function can be learnt. Next, we will move to the tan function. Tan function in a right angle triangle can be defined like this, or tangent of the angle can be defined as opposite side by adjacent side. So, this is how tan function can be defined as a ratio of right angle triangle, as a ratio of sides of the right angle triangle. This ratio is called as a trigonometric ratio. The same tan function can be defined as an algebraic function, trigonometric function as an algebraic function. Here in this table you can see both the sine value and cos value, finally the tan value. Why this is given here is this tan function is a function of sine and cos. That means tan value can be obtained by taking the ratio of sine and cos. You know the basic trigonometry formula, tan theta is equal to sine theta by cos theta. That is what happened here. So, here sine x is 0, cos x is 1, then ratio of these two 0 by 1 becomes 0. Then sine x, sine 45 is 0.71, then cos 45 is again 0.71. The ratio of these two gives 1. So, tan 45 is equal to 1. Then tan 90. Tan 90 is equal to sine 90 by cos 90. Sine 90 is equal to 1, cos 90 is equal to 0. 1 by 0 is equal to undefined, infinite. So, here that undefined symbol is given. Then 135, sine 135 is 0.71, cos 135 is minus 0.71. Ratio of this 0.71 and minus 0.71 gives minus 1. So, here this tan 135 is equal to minus 1. Then 180 degree. For 180 degree, sine value is 0, cos value is minus 1, then tan value is 0, because sine theta by cos theta, 0 by minus 1, 0 divided by minus 1, which gives 0. Then 225, for 225 sine value is minus 0.71, then cos value is minus 0.71, you got 1. So, here for 45 degree we got tan value as 1, then 225 degree we got tan value as 1. Then if you go to 270, the tan value is again infinite, undefined, that means minus 1 by 0. Then for 315 degree sin value is minus 0.71, then cos value is 0.71, then tan value becomes minus 1. So, for 135 we got the tangent tan of an angle as minus 1, then for 315 we got the tan value as minus 1, then for 360 we got this 0 value as 0. This is how the tan function is also a periodic function can be explained. Then I told you tan function depends on the sine function and cos function. We learnt that sine function is a periodic function with periodicity 2 pi. Then cos function is also a periodic function with periodicity 2 pi. Since tan function depends on these two functions, it is also a periodic function. Here you can see that the pattern repeats itself in a short interval. In cos and sine function, the pattern repeats after 2 pi radian or 360 degree, but in tan function the pattern repeats in a short interval. So, periodicity of this tan function is low compared to the periodicity of sine function and tan function. So, the periodicity of tan function is 180 degree or pi radians. So, tan function repeat itself after every 180 degree or pi radians. So, this can be equationally represented as f of x is assumed as a tan function, then the periodicity of this tan function is defined as it is defined equationally as tan x plus pi, or in general it can be written as tan into x plus n pi. So, this is how periodicity of tan function can be defined and explained. So, from this discussion we learnt that sine function, cos function and tan function are all periodic trigonometric function which is used in many physics and architectural problems. Then we learnt that the periodicity of sine function is 2 pi radians or 360 degree, periodicity of cos function is 2 pi radians or 360 degrees, periodicity of tan function is pi radians or 180 degree. Then sine function is defined as a trigonometric ratio as opposite side by hypotenuse. Cosine function is defined as a ratio of adjacent side of a right angle triangle to hypotenuse of the right angle triangle. Then tan function is defined as opposite side by adjacent side of a right angle triangle. So, this is how these three functions can be defined. Now, we will go to a problem which uses this trigonometric function. This is a problem. In this problem, height of the chimney is asked. Find the height of the chimney when it is found that on walking towards it 100 meters in a horizontal line through its base, the angular elevation of its top changes from 30 degree to 45 degree. So, a man walking towards the chimney, when the man distance is 100 meters from the chimney, the angular elevation of the top of the chimney appears to the man changes from 30 degree to 45 degree. From these data we are asked to find the height of the chimney. How can we approach this problem? We will see the problem. Solution to this problem is obtained like this. In the problem it is given that height of the chimney. So, let us make a point P as the top of the chimney, then base point as O, then height of the chimney is represented by the line OP. In the problem, we are asked to find the height of the chimney. Let us keep the height of the chimney as h. Then a man is walking towards the chimney in a horizontal line through its base. Then angular elevation of the top of the chimney changes from 30 degree to 45 degree. So this is the 30 degree angular elevation. Keep this point as A. Then keep this as the initial elevation. Then it changes to 45 degree when he approaches the chimney. Now this OA is equal to 100 plus h, 100 plus h. Now we need to solve this problem. To solve this problem, let us assume following things. Angle PAO is equal to 30 degree. That is what we have used here. PAO, which is equal to 30 degree. Then angle PBO is equal to 45 degree. Then AB is equal to 100 meters. AB is equal to 100 meters. That is what it is given in the problem. Walking towards it 100 meters. So keep this as point B. So this distance is 100 meter. In a right angle triangle PBO, in a right angle triangle POB. So from the figure, this POB is the right angle triangle. In that right angle triangle, this angle BPO is equal to angle PBO, which is equal to 45 degree. So here this is BPO and PBO. This is 90 degree. This is 45 degree, means this also will be 45 degree, because sum of all the three angles of a triangle is 180 degree. So PBO is equal to BPO. This is equal to 45 degree. Now OB is equal to OP is equal to H. Since the two angles of this triangle has become equal, that is this is 45, this is 45. So OB, which this is OB, is equal to OP. So that is equal to H according to one of the property of the triangle. Then we know that OA is equal to OB plus AB. Here it is used that OB is equal to H. So H plus AB is equal to 100 meters. So keep this as 100. The value of OA is equal to 100. Then in right angle triangle POA, tan theta is tan 30 is equal to OP by OA. Tan 30 value is 1 by root 3. Then OP value already we have taken that as H. Then OA value we took as H plus 100. Then manipulate this, we got root 3 H is equal to H plus 100. Then further simplification of this gives H root 3 minus 1 is equal to 100. Further simplification of this gives the value of H as 50 root 3 plus 1 meter. This is the height of the chimney in the given problem. So this is how we can apply trigonometric function to real life problems like this. So from this lecture we learned the definition of trigonometric function sine, cos, tan. We learned that sine function is a periodic function of period 2 pi. Cos function is also a periodic function of period 2 pi. Then tan function depends on sine function and cos function only. So tan function is also a periodic function, because sine function and cos function are periodic, tan function is also a periodic function. Then application of these trigonometric functions in our real life problem. These are all the concepts we learned from this lecture. After listening to this lecture, you can answer the following questions. Define sine function, give the pictorial representation of cos function, then solve the problem a plus b is equal to 45 degree, prove that 1 plus tan a into 1 plus tan b is equal to 2. This problem can also be proved. These are the questions you can answer after listening to this lecture. Thank you.